Hello, welcome dear students. Today we are discussing about some identities of trigonometry in 11th class. There are a large number of identities, so in very interesting way I want to discuss these identities first, and then we will start about the derivations of these identities, how they are coming. Okay, so please focus here. Some of the identities I am discussing you. Sin A plus B is equals to sin A cos B plus cos A sin B. Okay, if here is plus, there is plus also. Okay, sin A minus B, this is sin A cos B minus cos A sin B. Actually it is very interesting to understand how these identities are coming. So before discussing that, because that will be very difficult to understand, I can say. So before discussing the derivation, I want to show you how these identities are to be used to derive some more identities here, and then after that I will discuss with you the derivation of these identities too. Okay, so cos A plus B is cos A cos B minus sin A sin B, right? Cos A minus B is, there is plus in cos, then this is minus cos A cos B plus sin A sin B. Tan A plus B, this will be in this way, tan A plus tan B upon 1 minus tan A tan B. Okay, and this tan A minus B there, that will be tan A minus tan B upon 1 plus tan A tan B. Similarly, you can calculate the identity for cot A plus B also. This is cot B plus cot A, 1 minus cot B cot A, and cot B plus cot A. Okay, and this is 1 plus cot B cot A, and this is cot B minus cot A. Okay, so you need to learn all these identities. Now by using these, how we are getting sin A plus B plus sin A minus B. So if we'll add these two, sin A plus B plus sin A minus B, we will see here this is plus cos A minus B minus cos A minus, this will be cancelled out. Twice of sin A cos B will be left, twice sin A cos B. Similarly, by subtracting this from this, if we will change minus sign here, then this will be plus, it will be cancelled out to 2 cos A sin B, 2 cos A sin B. Similarly, if we'll do cos A plus B in these two, adding these two, this one and this one, adding these two identities, so these two will be cancelled, 2 cos A cos B will be here, 2 cos A cos B is here. Okay, cos A plus B, if we are subtracting this, minus and minus here, so we cancel the minus 2 sin A sin B. We can also write this in this way, if we are replacing this minus this, so plus 2 sin A sin B. Okay, right. If I am replacing here in these two identities, these one for A plus B is replaced by C. I am solving here. A plus B is equals to, we are substituting C and A minus B को हम D substitute कर रहे हैं, तो by adding 2A will be equals to C plus D, so A will be equals to C plus D by 2. And similarly, if we subtract A plus B को C put कर रहे हैं, A minus B को D put कर रहे हैं, और subtract करेंगे तो A कट जाएगा, 2B will be C minus D, so B will come C minus D by 2. In place of b we will put this, in place of a we will put this. If we will replace a plus b को c से और a minus b को d से. Okay, so here please focus on very important. Sin a plus b is c, sin a minus b is d. So this will become 2 sin c plus d by 2 into cos c minus d by 2. So this will be there, 2 cos c plus d by 2 sin c minus d by 2, and this is 2 cos c plus d by 2 into cos c minus d by 2. Here minus 2 sin 2 times sin c plus d by 2 into sin c minus d by 2. Okay, after replacing a by c plus d by 2 and b by c minus d by 2, we got this. How we are getting multiples of two angles? See, dear students, if in this identity we will replace b by a, so a plus a is 2a, so we will get sin 2a. In this case, sin a cos a plus sin a cos a, because we are replacing b by a, so sin a cos a plus sin a cos a, so 2 sin a cos a, 2 sin a cos a. Okay, sin 2a की one more identity, 2 tan a upon 1 plus tan square a. कैसे आई बाद में प्रूफ डिस्कस करेंगे. Here cos 2a is, you are replacing b by a, cos a was a, cos a plus a is 2a, so cos square a minus sin square a. टेंथ आइडेंटिटी, sin square a को हम 1 minus cos square a लिखें तो 2 cos square a minus 1, और cos square a को 1 minus sin square a लिखें तो 1 minus 2 sin square a. ओके, ऐसे ही cos 2a की tan में आइडेंटिटी एक और होती है, 1 minus tan square a upon 1 plus tan square a. ओके, इसको भी बाद में डिस्कस करते हैं. tan 2a, this is here, tan a plus b, tan a plus tan a, 2 tan a upon 1 minus tan square a. यहीं से हमारे पास ये आइडेंटिटी बन जाएगी, 1 plus cos 2a. If we are taking 1 in left hand side, 1 plus cos 2a will be 2 cos square a. Similarly, 1 minus cos 2a will be there, and there 2 sin square a. 1 plus cos 2a is sin a plus cos a whole square. If we will open this identity, sin square a plus cos square a will be 1, and plus 2 sin a cos a will be sin 2a, so we will get 1 plus sin 2a. And this is sin a minus cos a whole square. Okay, so by using these all identities we can have half angle formulas. If we have sin 2a is equals to 2 sin a cos a, so sin a will be equals to, sin a is 2 sin a by 2 cos a by 2. Like this we will write all the identities there. Another identities of sin a, 2 tan a by 2, 1 plus tan square a by 2. Okay, similarly for cos a, so we have cos square a by 2 minus sin square a by 2. One more, cos a is equals to 2 cos square a by 2 minus 1, and one more identity of cos a, 1 minus 2 sin square a by 2, and another one in tan, 1 minus tan square a by 2, 1 plus tan square a by 2. Another identity, tan a, so 2 tan a by 2 upon 1 minus tan square a by 2. Okay, dear students, so you can also write here these identities too in half angle formulas. 1 plus cos a will be equals to 2 cos square a by 2, 1 minus cos 2a, 2 sin square a by 2. 1 plus sin a is equals to sin a by 2 plus cos a by 2 whole square. If we are taking half of this, then we will do half of this. Okay, like this we will go through this. Okay, some more identities we have. We need to understand this also. So after that we will do derivations too. Sin 3 is 3 sin a minus 4 sin cube a, 4 cos cube a minus 3 cos a, tan 3a is equals to 3 tan a minus tan cube a upon 1 minus 3 tan square a. How these are coming we can prove later on. And now some multiples of 3. If we are taking a, then the here will be a by 3. So 3 sin a by 3 minus 4 sin cube a by 3, a by 3. Okay, cos a, 4 cos cube a by 3 minus 3 cos a by 3, tan a, 3 tan a by 3 minus tan cube a by 3, 1 minus 3 tan square a by 3. ये मैंने पहले से आइडेंटिटी लिख दिया है. sin a plus b को sin a minus b से मल्टीप्लाई करेंगे तो यू कैन राइट दिस ऑल्सो एंड यू कैन राइट दिस ऑल्सो. sin स्क्वायर a माइनस sin स्क्वायर b और cos स्क्वायर b माइनस cos स्क्वायर a. कैसे आएगा 1 माइनस sin स्क्वायर a को 1 माइनस cos स्क्वायर लिख लेंगे, sin स्क्वायर b को 1 माइनस cos स्क्वायर b लिख लेंगे तो सॉल्व करके आ जाएगा. Like similarly we have this one identity also. Okay, here ये मैंने आइडेंटिटी ऑलरेडी लिख दिया है, ये आप इसको लर्न कर लेंगे. सम सॉल्यूशंस ऑफ ट्रिग्नोमेट्रिक इक्वेशन, जैसे हम 3x माइनस 15 इक्वल्स टू 0 करेंगे तो x की वैल्यू 5 आएगी. ऐसे ही साइन थीटा इक्वल्स टू 0 होगा तो थीटा की वैल्यू क्या हो सकती है, n पाई, n कोई भी नंबर हो सकता है, 1 पाई, 2 पाई, माइनस 2 पाई, एनी वन, that value will be 0. Cos theta is equals to 0, theta is equals to this, tan theta 0, theta is equals to n pi. If we have sin theta is equals to sin alpha, then theta is equals to n pi plus minus 1 raised to the power n into alpha. These n can be any integer, right? Cos theta is equals to cos alpha is this, sin tan theta is equals to tan alpha is this one identity, very important. But in case of square, sin square theta equals to sin square alpha, cos square theta is equals to cos square alpha, and tan square theta is equals to tan square alpha. For all these three, we have only one identity. Theta is equals to n pi plus minus alpha for all values of n belongs to z. Correct? आप इन सभी आइडेंटिटीज़ को याद करेंगे, डेरिवेशंस हम एक एक करके करते जाएंगे. जो चीज़ें आप NCERT से या बाहर से कर पाएंगे उनको आप कोशिश करिए, जो नहीं आती है आप मुझसे गूगल ऐप पे पूछिए. ओके, so this is the combination of all the identities which we will use in this chapter. Okay, dear student, so please try to understand. I'll explain you derivations of these identities one by one, because first you understand this, that there is a combination of identities which is required, and what are those identities, this is that. Okay, thank you very much, thanks a lot.